Assalamualaikum and hello. In this video, I'm going to continue with the last part of our chapter 6 where we are going to focus about anomalous behavior of the first ionization energy. In a previous video, you've learned what is the definition of first ionization energy, and you know how to use the layout in order to explain about the trend for first ionization energy of period 2 and period 3. So in this case, I'm going to explain to you about the anomalous behavior for selected elements across period 2 and period 3. Basically, when we want to describe the size of element across period 2 and period 3, we will use factor effective nuclear charge, where the acronyms is going to be PISAs. So as you see here, you got PISAs, which the proton number increase, effective nuclear charge also increase, and then the attraction also increase, making the size become smaller. So PISAs only can be used when you want to explain the trend of atomic size for any elements across the period. So when the size becomes smaller, more energy is needed to remove the electrons. So that's why the first ionization energy keeps increasing across the period. But what I want you to take a look carefully based on this diagram, we can see that across period 2, from lithium to neon, the first ionization energy keeps increasing because the size keeps getting smaller. But there is anomalous behavior. Maksud anomalous adalah kelainan ataupun something very different ataupun weird. So as you see here, first ionization energy keeps increasing, tapi ada anomalous case for element between beryllium and boron. Tiba-tiba graf dia menurun. And same case with elements nitrogen and oxygen, it decreases. So inilah yang kita akan explain kepada dua bahagian untuk period 2, where we are going to use the same case for magnesium and aluminium and also phosphorus and sulfur. Tapi saya hanya explain salah satu sahaja supaya awak clear kenapa anomalous behavior ini berlaku. So let's go with the first part in between the elements of group 2 and group 13. So you have beryllium and also boron. So what is the electronic configuration for beryllium? Beryllium is going to be 1s2, 2s2, because we have 4 proton number for beryllium. And then for boron, we have 5 proton number, so the electronic configuration is going to be 1s2, 2s2, 2p1. And in this case, I write my electronic configuration in SPDF notation. But to explain more clearly to you, I will use another method to write the electronic configuration, which is by using orbital diagram. So for beryllium, is going to be Be equals to 1 line for 1s and 1 line for 2s. So I'm going to label my orbital, and after that I fill the electrons, 2 of them in each orbital. And the next one, for boron, I have the symbol for the boron, capital B, and I will have 1 line for 1s, 1 line for 2s, and 3 line for 2p. So now I'm going to label my orbital as it is, and I'm going to fill the electrons, 2 electrons in 1s, 2 electrons in 2s, and 1 electron in 2p. So what can you see from this orbital diagram? You can see that for beryllium, you have fully filled 2s orbital. So this is going to be fully filled 2s orbital. However, if you take a look at boron, you can see that for 2p orbital is just partially filled. So this one adalah partially filled 2p orbital. What can you deduce here? You can say that more energy is required to remove electrons from beryllium. Why? Because when you have fully filled orbital, it's much more stable than when you have partially filled orbital. So the key terms that you have to know in this case adalah term fully filled, which is more stable than half filled and more stable than partially filled. So this is the least stable and this is going to be the most stable. So in this case, which one is much more stable? Fully filled is much more stable. Sebab tu daya tarikan dia sangat kuat dalam 2s orbital untuk elektron tersebut. So maknanya more energy is required to remove electrons from beryllium. So a bit more information. Why? Because electronic structure for beryllium is more stable than what we expected. So this one is much more stable because electrons in 2p of boron is higher in energy. So bila dia higher in energy, kerana kita susun mengikut akhbar, 2p lebih tinggi daripada 2s. So bila dia higher in energy, dia less stable. And that's why easy to remove the electrons. So the first ionization of beryllium is higher than boron. So that is the explanation how you want to describe about the anomalous behavior for elements in between group 2 and 13 for part 1. Now we go to part 2, the elements between group 15 and 16. Dalam kes ini adalah untuk nitrogen dan oxygen. So macam mana kita nak explain for that one? We go to the next page where we have nitrogen and oxygen. And of course, you have to write the electronic configuration. But right now, straight away, saya akan tulis electronic configuration dalam bentuk orbital diagram supaya awak nampak dengan lebih jelas how much the electrons feel in that orbital. So I got nitrogen with proton number 7 and I got oxygen with proton number 8. So based on my orbital diagram for nitrogen, I have 1s, I got 2s, and then I got 2p, and the next one, I'm going to fill the electrons, which is 2 electrons in 1s, 2 electrons in 2s, and so 4 electrons already used up. So I got 3 more left, 1 in each room of 2p orbital. So as you see here, in 2p orbital, you got half fill 2p orbital. Okay, and the next one I got 8 proton number for oxygen. I'm going to draw the electronic configuration for oxygen. So I got 1s, and then I got 2s, and then I got 2p. And after that, I'm going to fill the electrons. So it's going to be 1s2, 2s2, and then 2p4. So 1, 2, 3. Follow the Hans rule and Aufbau principle. And after that, one more at the front in the first room of 2p orbital. And when you see here, you got 2 electrons yang tiada couple. So maknanya dia kita klasifikasikan sebagai partially filled 2p orbital. So as I mentioned before, between partially filled and half filled is more stable. Okay, so what will happen when you see that half filled is more stable? So it means that more energy is required to remove the electrons from nitrogen. So this is where you put the words more energy. So which means that first ionization of nitrogen is higher than oxygen. So a big explanation. More energy is needed to remove the electrons from nitrogen. It means that half-filled 2p orbital in nitrogen is more stable than partially filled orbital in oxygen, as I explained before. This is because the 2 electrons that occupy in the same 2p orbital, as I highlight here, in oxygen experience considerable electron-electron repulsion and are easier to be removed. So bila dia mudah untuk remove, maknanya less energy is needed. Bila dia susah untuk remove kerana stability dia sudah hampir pada fully filled orbital, maknanya energy yang diperlukan lebih banyak. So itulah konsep secara logik yang awak perlu tahu. Dan sekarang sudah settle about the anomalous behavior for selected elements across period 2. So the same explanation you can write for magnesium and aluminium and also phosphorus and sulfur. I just explained one of the period only. So far, as I mentioned before, this is going to be the last video for our chapter 6. So I hope everything is good for you. I know there are a lot to absorb, but please remember you have to read the questions carefully and follow the tips. No matter what, you have to write the electronic configuration correctly first. And please use the layout based on the factors that you need to explain. And make sure you understand the key points of each trends that I explained in terms of periodicity. Then, if you follow my instruction carefully, everything is going to be well for you. So I hope you can try to answer exercise from Try This 7.0. And then, congrats, we're done with chapter 6 predictable. And please try to do your best in chemistry. I hope everything is going to be smooth for you. So that's all from me in this video. I'm going to see you in the next chapter. Thanks for watching. Bye.